Hi, everyone. I'm gonna make this short because it's almost the end of this conference. So my name is Qing, and I'm from Lakehead University. Because for librarians have been building digital collection for years. Why I present this is it hard and difficult to build digital collections in 2022? No, it's not, but there's a lot of pitfalls. Today's presentation, I like to share the lesson I learned and the experience using Omeka to build digital herbarium collections. So in this short presentation, I'm going to touch upon challenges, workflow, implementation, and customization, those aspects of building a digital herbarium collection. Herbarium collection at the Lakehead University was established in 1969. About 100 species, including conifer flowering plants, ferns, etc., and collected from northern western Ontario. So far, there are about 110,000 herbarium specimens in the herbarium collections at the Lakehead. So everything starts from a phone call. A couple years ago, I got a phone call from a prof at the biology department. He asked me whether I can help him to post some digital image on the web. Initially, those type of stuff, the challenge I list here came into my mind. If it's a very legit type of a project, I need to look into all those aspects. Still, when I look back, still those challenges are still relevant. The first one is how to create a digital presentation of herbarium specimens. Digitization process need to be set up properly. The description process, the web presentation, not just put the image there. Of course, there's a whole lot of things involved, and long-term preservation often missed out in digital collections when we built, and the whole workflow, how to put things together. So as the prof mentioned, just want to present the digital images on the web. After a couple of meetings with the department, they want web presentation, of course, but not only that, but a system have functionalities. It's searchable, can display geolocations on the map, ability to add and update metadata and images, interoperable with other repositories, and preservation as well. So for because at the Lakehead we have a small team, we sit down and examine the data flows in the project. There are two major type of data in this project. One is image, so another is metadata associated with each image. We took a data-centric approach, like the diagram showing here is a data flow through the system, from the image capture to image processing and store images and publish digital specimens and archive digital specimens. Although from here it's only the published digital specimens has something to do with Omeka. There's other steps we have to go through in order to reach the Omeka's part. As I mentioned again, the prof said they want me to help to post digitized images on the web. Apparently, they already implement capture a device, they DIY a photo box to digitize specimens using Canon 60 camera. Luckily, they haven't done nothing major wrong. So when they create the digital specimens, they save their initially save into JPEG files, but they also save CR2 files as well. So it wasn't a major mistake, but still we be able to adjust, have a conversation with the department and ask them to adjust the digitization process, and we can retrieve the CR2 files only, not the JPEG file. After all those preparation, they also, for metadata, they do manual entry put into an Access database. That's their own workflow before the Omeka S. Because we at Lakehead we are a small team, we wanted to build something which can be used by other projects. So when we talk about images, we look into IIIF image server, because the IIIF has benefits, being able to create tiles and transformation, ability to retrieve any region of original images at any size, quality and format. And so we implemented the IIIF image server. So after all those preparation, then we come to what type of system we're going to use to host the more like a digital content management system to be at the central hub for all those. Because we are a long time, Lakehead is a long time Omeka user. We had a quite good experience using Omeka. So that seems to be a very natural choice for us to look into the Omeka S 3 years ago. And the Omeka S is supports linked data, but we figured out the support is not as good as we expected. Supports IIIF images. That part is pretty much good. And the last one, the powerful CSV import, is really important for the project like this. So after for installing Omeka is quite straightforward. Omeka is by default when you install the Omeka is, there are 4 vocabularies by default already installed. That's but those vocabularies are not enough for Herbarium project. In order to preserve the raw data, so we created the Lakehead University Herbarium raw data vocabulary. So which consists 46 properties. In order to ensure interoperability, we imported simple Darwin core metadata schema, which is widely used in biological diversity community. They use that to share data between repositories. because there's another one, it's called a Darwin Core, which is a full version. That's more complicated than simple Darwin Core. The reason why we choose the simple Darwin Core, because the full Darwin Core is too strict. And when I evaluated the raw data set, it's no way to match with the full Darwin Core. And the simple Darwin Core that can be easily matched between the raw data set to the simple Darwin Core. So after we created the two, have two extra vocabularies into the system, we used powerful CSV import to import metadata along with IFFF images into the system. The powerful CSV import, you can make the metadata coursework between the raw data set, raw data vocabulary, and a simple Darwin Core. So that's was quite easy in terms of loading raw data. Oops, I think this is the wrong version. And as I mentioned before, one of the other requirements is that we needed to display geolocations on a map. And we have to do some customization to the map module of the Omeka, because by default the map module of Omeka only allow display 5,000 geolocation markers. We have to do some customization to display more than 5,000, because right now in our database it's over 30,000 geomarkers. There's quite a big challenge to do that. The reason why they put 5,000 there, because it's too slow to load more than 5,000 markers altogether. So we have to figure out different ways to load markers on a map. So we customized the map module. In order to support that modification as a customization, we also created a module called a map helper in order to display a map like this. This is the when you mouse over a specific geolocation marker, you're going to see the title of this item and the thumbnail of this item. So when you click on the item, you reach the item page. That's going to be displayed the map and some simple Darwin Core data field. For us, because the raw data sets properties, we don't want people to be able to see it. For Omeka, it has a quite powerful bulk type of action functionality. You can quite easily hide a whole lot of things from the public. So in the process, there's some lesson we learned. We need to investigate more before we start. For example, the map 5,000 limit, we didn't really expect that. And we need a clear requirement. The clearer requirement, the better, the easier for us to work with. And building project on open source application can be very challenging for a small team, because of my team, just myself and one other technician. So we have to try. We tried to make things more efficient as possible when we talking about making choices, like what type of tool we're going to use, what type of technology we investigate in. That's very challenging for us. We have to be very careful. And again, Omeka is very powerful and flexible. But during the implementation, we do see there are some enhancement we would like to see. For example, we load the data not just one time. They're going to be continuing load new data into the system. We have the powerful CSV import, but we don't want to do the cross map every time when we load the CS file, because it's 46 properties. We are looking into create an import profile type of module with the CSV import to make things easier. And that's pretty much about my presentation.
Dr. Zuo, thank you so much. If you want to remain center stage, you can stay at the podium and we'll just read the questions off if they should appear. Okay. Really fantastic process and project, making that information available from almost 50 years ago. Now people could study it, have access to it. So that's wonderful. Are there any questions for Dr. Zuo? I believe there's one question coming. Okay. The technology is lagging. Okay. So the question is the Herbarium Omeka S database available to the public?
Yes.
Okay.
Yeah, I'm gonna put the URL because I forgot to put the URL along with my presentation. No, not a problem. I can send that.
That's okay. That would be great if you share that. Thank you so much. And another question is on its way through the air. So the question is, what makes Omeka S different from Omeka? Did you look at the quote-unquote classic Omeka?
Oh, yes. Yeah, because we have quite a bit experience working with Omeka Classic. Put it this way, initially we look into because the project started about 3 years ago. At that time we looked at the Omeka Classic, which going to be very challenging to accommodate the data fields we wanted to include it into the digital herbariums, because for the Omeka Classic you have to create a completed set of data properties in the system in order to do the similar things Omeka S can handle. Because for Omeka S, it's automatically building supports vocabularies. We created the raw data set, raw data vocabulary. Our raw data can easily preserved, and in the same time, it's quite easy to import the simple Darwin core, and the metadata crosswork can be done easily when we load the data. So that's make a whole lot easier for us to use Omeka S instead of Omeka Classic.
Wow.
But we didn't expect the mapping part, because mapping for the Classic, there's no 5,000 limit. But for the S, there's a 5,000 limit. And for there are another one is Omeka Classic is better. It's you can easily export your item data as a linked data, but for Omeka S, there's no such thing available yet. We are looking into that part as well. because as I mentioned, the whole collection is over 110,000 specimens. That's going to have a whole lot of burden for if we continue to use Omeka, as we are looking to the ways to enhance our Omeka system. May have to look into other type of different ways to enhance the system.
So many considerations. That's fantastic. So another question: how do you handle the storage of images, S3 style object store or file system?
Right now, that's also the pain point of this project. Right now, we have our local installation, a local server, local storage to handle images. Because at this point, we only have about 3,000 images. Each image is about 120 mega for the master file. So the pressure is going to be keep coming. 3S are going to be something we are going to look in the future, but that's going to be very challenging. Not very challenging. It's going to be a different way to have to look into how to incorporate that along with the Omeka S, because for Omeka S. For S3 object storage, that's just, if I remember correctly, there may be some module already available, but how mature it is, how easy to integrate with IIF, that's still questionable. So we needed to look into that aspect as well.
Wow. And maybe just to wrap up, just a comment. Well, there's one more question. Maybe we can take that one as well. But comment, shout out to Cantaloupe, which is an underappreciated project. So there are some people that also support the same systems that you're looking at, which is great to know.
Yeah, that's great.